Bismillahirrahmanirrahim. Assalamu alaikum. My name is Professor Dr. Rizwan Jamil Qureshi, and I'm starting the lecture number 2 of Software Engineering 2, which is normally called Advanced Software Engineering at undergraduate level. In the last lecture, we were talking about what are the quality attributes of good software, and in the maintainability, we covered corrective and adaptive. So there are 4 types of maintenance: corrective, adaptive, perfective, and preventive. Corrective adaptive is covered in lecture number 1. Perfective. So what is perfective maintenance? Yes, Mr. Abdullah, Mr. Sam, Mr. Khalid, Mr. Faisal? No. Okay. There is nothing perfect in this world except Allah. We are human beings. We do mistakes. We learn by mistakes. And how is it possible that we develop a software which is perfect? So we do perfective maintenance to achieve the perfection. Try to make it as good as possible. So update and upgrade part. Go back to the definition of maintenance. What is maintenance? Yes, Mr. Hassam, Mr. Abdullah, Mr. Khalid, Mr. Faisal. Okay. Maintenance is a process to fix the bugs and update or upgrade the software. Fix bugs is corrective. Update and upgrade is the perfective maintenance. Then you have preventive maintenance. Yes, Mr. Hassam, Mr. Khalid, Mr. Abdullah, Mr. Faisal. Any answer? No. We cannot forecast errors. We are not magicians that we can prevent the errors before they occur. No. We have corrective maintenance, adaptive maintenance, perfective maintenance. During the life of software, we performed all these maintenances, updates, upgrades. So after a certain period, its quality goes down. We have one of the attributes of software. Software doesn't wear out, but it deteriorates. What is the meaning of deterioration, Mr. Hussam, Mr. Khalid, Mr. Abdullah, Mr. Faisal? Deterioration means lack of quality. Software never becomes obsolete. It never becomes outdated because it's not physical thing, it's a logical thing. And like hardware or car or human being, we suffer from wear out. We have young age, we have elderly age. So like child age, when you born you are weak, when you are elderly you are again weak. So same other products like hardware, it has age. So aging affects to humans physical things, hardware, car, factory, houses, but software is logical, like spirit. Spirit has no age. It's created by Allah at the beginning of this universe, this world, and it doesn't have age. But when we born, our age starts and we suffer from aging after the age of 40 or 50 or plus that. Software is physical, so it doesn't suffer from wear out. It never becomes outdated. It has no age, but it suffers from lack of quality because of temperature, pressure, humidity. No, it's all related to hardware. It suffers from lack of quality because of corrective maintenance, adaptive maintenance, perfective maintenance, and we have to prevent perform preventive maintenance to improve the quality of software. Like we have legacy system. What's a legacy system, Mr. Hussam, Mr. Faisal, Mr. Abdullah, Mr. Khalid? Legacy systems are old systems that were developed in 1970s, 80s, 90s. And during their life of like 30 years, 40 years, 50 years, Pakistan Electricity Company, like Saudi Electricity Company, they have a billing system, and that was developed in 1970s, and the programming language is used COBOL, and COBOL is a file-based system. It doesn't have connect to the database, so it stores data of entire population of Pakistan, including homes, factories, governments, private sector, public sector, all that. And till today, it's in use about 52 years. So during the life of 52 years, it suffers from, you have bugs, you fix the bugs, you update it, you upgrade it. Because of that, it becomes slow and its size increases because of updates, upgrades. And when size increases, cause and effect relation. What is the effect? Yes, Mr. Hassam, if you increase the size of software, what happens to software? Complexity. If you increase the size, complexity will increase. Like Microsoft Vista failed because of large size, and Microsoft tried to make it more functional, and its size increases so much, like 50 million plus lines of code, approximately 70 to 80 million lines, but it is never disclosed. So approximately, if it is 50 plus million line of code, it's extremely difficult to test the whole software, and that was the reason there were so many bugs. It was not stable, and it was failed product and worst operating system introduced by Microsoft. Same is the case of Symbian operating system by Nokia. Nokia tried to add so many functionalities, size increases, complexity increases, and it failed. And Samsung captured the market, and no more Nokia is popular. Same is the case of Netscape Communicator browser. There was very popular browser early 2000, and nobody used Internet Explorer. That time Chrome was not there. But then the company decided to add more functionalities, and size increases, complexity increases, and it failed. Now there is no more Netscape Communicator browser. So these are three popular examples when you increase the size, complexity increase, and it failed. So you have to perform preventive maintenance to improve the quality of software. Like how you do preventive maintenance? You decrease the size to decrease the complexity, because size increase, complexity increase. You decrease the size, complexity will decrease. Like the case of Windows Vista, Microsoft removed 30 million lines from Vista, and then Windows 7 was introduced, and it was much successful. And we have a term, it's called MMF, minimum marketable features. Don't try to add extra features. Or we have minimum viable product, that you can MVP. There is a term also introduced in the business sector, that minimum viable, that customer can purchase. Don't increase the price, don't increase the functionality. So how you decrease the size? Removing unnecessary features, unnecessary functionalities, unnecessary lines. And when you decrease the size, like a fat guy, it is difficult for a fat guy to move and perform its daily routine, daily activities. When that fat guy reduced his weight, it becomes smart, and he can easily perform his duties, his activities. It becomes smart. Same software, because of large size, it takes more time to load, it becomes slow, lot of bugs, more maintenance is required, more maintenance cost, maintenance time, effort, all are related to that. And when you do that by removing unnecessary features, unnecessary lines, it becomes smart, it becomes reduced complexity. In terms of complexity, its complexity is decreased, and then it takes less time to load and becomes efficient. So that's the fourth type of maintenance. So maintainability mean easy to fix the bugs, easy to update, easy to upgrade. That's the maintainability. Then integrity is another quality attribute. It's not integration, it's not integrity, it's integrity. So Mr. Hassam, Mr. Abdullah, Mr. Khalid, Mr. Faisal, there are two types of integrity. We have data integrity and software integrity. Data integrity means data is reliable. You have taken from authentic source like BBC, CNN, Al Jazeera, IEEE, ACM, elsewhere, or Microsoft official website, Oracle official website. So that's authentic data. You can trust on that data. You can use that data. But we ask the students, don't use Wikipedia, Webpedia, because they are not reliable sources. Anybody can change. You can change. Faisal can change. Sam can change. So data integrity means data is reliable. It is taken from authentic source like books. Then you have software integrity. Software integrity means software can protect itself from unauthorized access. So you have applied security technology. That's the software integrity, like you have applied firewall, digital certificate, cryptography, encryption, decryption, antiviruses. So that's the related to integrity. Portability is another quality attribute. Portability means your software can run on multiple platforms like the adaptive maintenance. So it's covered in portability. It's portable, like we say Java is portable. Flexibility. Flexibility means easy to update, easy to upgrade, easy to reuse. That's all under the flexibility. Then acceptability. Acceptability means user satisfaction. How many percentage of users are satisfied, like Microsoft? Because of usability, it is widely accepted. And Linux, Unix, because they are not widely accepted in terms of client operating system, their acceptability is low. If acceptability, user satisfaction is less than 50% or equal 50%, change the design. That means software company is not practicing UXD. What is UXD? U for umbrella, X for Xbox, D for donkey, Hammar. Am I correct? Yes, Mr. Faisal, Mr. Faisal, Mr. Hassam, Mr. Abdullah. User experience design. That means users were not involved while approving the design of software. So that's the acceptability. Then you have dependability. How you can, by word, by meaning, shusme yani, dependable mean trustable. How you can trust on software? How you can depend on software? Yes, Mr. Hassam, Mr. Khalid, Mr. Abdullah, Mr. Faisal. Anything, what comes to your mind? How you depend? We normally depend on our father or our, we say in general, parents, friends, brothers, sisters, uncle, auntie. But how you depend on a software? There are 7 dimensions of dependability. Availability, reliability, safety, security. These are the four. First, I will cover availability. Software must be available to its users 99.999%, like 24 by 7, 365 days a year, like Google, e-commerce websites like Amazon, eBay, AliExpress, Desert.com, banking websites. So that's the availability. Its downtime is 0.0001 and uptime should be 99.999%. That's the availability. Then you have reliability. Reliability means software should have minimum bugs. It is not possible that we don't have any bug, because as I just mentioned few minutes before, we are humans, we do mistake, so it's not possible the product we develop doesn't have any bug, but should have minimum bugs. And it should be stable, it should not crash again and again. That's reliability. Like Linux, Unix are highly reliable and Windows is highly unreliable. Why? Linux, Unix are open source, whereas Microsoft Windows is closed source. So it's only fixed in terms of bug fixing is done only by Microsoft programmers, whereas Linux community, Unix community is public. It's under the journal. Anybody, any programmer in the world can fix the bug. So as soon as any bug is reported all over the world, the programmers start trying to find out solution how to fix that bug. So they start bug fixing process. They start maintenance as a bug is reported. So there is no comparison of limited number of programmers, maybe 50,000, 60,000 as compared to millions of programmers of Unix and Linux. So that's the reason Linux, Unix have minimum bugs and Windows never try to focus on maintenance, because they know it's not strength of company, it's their weakness. So they focus only on usability, which is their strength, which is the strength of Microsoft. So they, as soon as a bug is reported to Microsoft, they just introduce a patch, exception, khalas, khali wali. So that's the process followed by Microsoft. So that is the reason it is not reliable, it is highly unreliable. Then you have safety and security. What is the difference, how you distinguish between safety and security? Yes, Mr. Faisal, Mr. Khalid, Mr. Abdullah, Mr. Hassan. Security is related to data theft, whereas safety is related to risk related to humans, the risk related to humans. So we have safety critical projects where human life risks are involved, whereas security is related to data theft. So spoofing, sniffing is that, taping, these are different terminologies. So what are the safety critical projects? Where human life risks are involved. For example, Mr. Faisal, Mr. Hussam, Mr. Khalid, Mr. Abdullah. For example, flight control system, autopilot, auto car, driverless cars. These all are few examples, common examples. Airbag, fire alarming system, then nuclear reactor control system, like the case of a space shuttle system, like the case of Challenger. space shuttle. It was blasted within few seconds after it was fired, and 11 astronauts, 11 people died because of that accident. And it was an error. Because of that, this accident happened and 11 people died. Nuclear reactor control system, like the case of Chernobyl nuclear power plant, it was exploded in 1980s and approximately 3.5 million people were affected. And from 1980s till today, in that area, no human can survive because of very strong radiations of uranium and plutonium. And now the Hakuma is trying to cover it, shield it by cemented blocks to stop or reduce the radiations. But in Japan, tsunami hit to nuclear power plant and they have safety measures and no human was affected. So they have safety measurements. Toyota Land Cruiser 2011 model, if you increase the speed to 100, it automatically increased to 200. So then Toyota company freely replaced that part. Airbag. Nissan company suffered the airbag problem, that because of accident passenger was not hurt, but because of shock of airbag there were fracture in the bones of front driver and the front passenger. So that's the problem of Nissan company. Then they freely replaced the airbags. Similarly, there was a Boeing company model, the Airbus and the Boeing company are two popular companies. The Boeing company plane suffered that one of the models, the fuel shows it is full, and the pilot took off and for traveling to its destination, and suddenly it was not full, it was empty. First engine stopped, there were 4 engines, second engine stopped, third engine stopped, fourth engine stopped, and finally there was no electricity. Luckily there was a car racing track downwards and there was a car race on that track, but there were 2 tracks. So second track was empty and the pilot landed the plane there and safely, and no injury, no death was reported. Then Boeing company replaced that part. So these are few examples. Then robotics are the also common examples. Automation, factory automation, I will cover inshallah in the next lecture. Thank you very much. Jazakallah khair. May Allah bless you. Assalamu alaikum.